shapes. 1, 2, and then 3 and 4. Admittedly, these two were a bit further back, but still.
Oh my god, it picks it up from that distance. Welcome, welcome, welcome. Hello everybody, I got fresh coffee. Yeah, that's what I was doing. Windows 10. Yes, we're on it. Okay. What do I do then? Oh, that was it. I do that. Yay! Welcome to the stream. I've made a few decisions. This is going to be just a stream in the afternoons where you join in on what I'm doing at that time, because I want to work on this offline as well. I want to get this done. It's very important to me that this gets done. In fact, it's the only important thing I'm doing right now. My name's Fraser Sharp, if you didn't already know. Some people call me Blades. Some people call me other things. Hey. So here we go. We've got Visual Studio 2019. It's already preloaded with what we've done so far. And yeah, here we are. Let's have a look at this microphone. Hello, microphone. Oh, clean keyboard. Who did that? I don't know. And we're off center. That's fine. Everything's off center today. Is that correct? It is, but why? Oh God, what's happened here? All right, use Visual Studio and just move it until it goes clean on both sides. That looks good. Yeah, things have moved. Don't know why. Let me just move that over. Lovely. We've got chat. We've got chat. Hello. Alright, everything's set up now. Oh, grief. So, what I've been doing for the last couple of days. Well, what we're doing, actually. What is this stream? Get that keyboard off there. A minute. Does it tell me what I'm doing? So look on chat board. Day 4 rendering textures. Is that what I'm doing? Alright. Oh, I've got rendering up. And this has textures, I'm guessing. Right, so what I've been doing the last couple of days. And why wasn't there a stream on Sunday? Because I came across something whilst rendering textures. Well, whilst I was sorting out my textures. Came across something I didn't like. The SDL2. I'd show you, but it's been deleted. I didn't want it. So, let's go backwards just one step, because we're rendering textures. So, where are the textures? The textures are in the model warehouse. It's all been set up now for me. By me. Luckily. The warehouse, we've got all the requests. We can request the handle, the index, and the textures. So that will give me a model index, and texture. Okay, we've got a loader for the model, which is ASIMP. We set up the VAO. I've changed all of this around to see if it works, so that instead of doing all of this mem copy stuff, which I was doing before, I'm just going to set up the mesh and try and dump the indices straight into the data buffer. That's where I was using face array there. Okay, so that's the changes that I want to test. Probably won't work, no my luck. Vertices has remained the same. Normals have remained the same. Except they're on 1 now instead of 2. UV coordinates have been added. They're on 2 now. So that's the UV coordinates there. Mesh M textures coords. There you go. Obviously I didn't need face array, so that went out. Texture loading. Oh, this is different. Right. There's a gotcha in this. That I will instantly talk about before I continue, because this is loading the texture. So the first step to writing this lovely texture loader is at the top of the screen. So I'll go back up. And what you do is you download stb_image.h, and that will be found on GitHub. It's done by Nothings, Nothings. STB is what you're looking for. Nothings/STB. Can I pull that up? So GitHub. Let's see if I can find it. I may as well tell you what I'm using. There it is. Search GitHub. I'll go for Nothings first. Alright, that's coming up with a load of rubbish. STB. It's a library. There you go. First hit on STB. Nothings. STB. This. Download it. It's got a load of good stuff in it, and I mean good stuff. Which it's all noted within the files on what to do. Okay. It's also got a full README section here. So download the lot. And we are after stb_image.h there. Graphics, image loading, decoding from file memory, JPEGs, PNGs, which is what we want. And it does everything else as well, so you can use anything with it. Alright, so that's the one that we're using. which is there. Okay. I'll just put it on screen. You just download the lot and just drag this one out and put it in your source/OpenGL directory. And I think, did I add it to the did I add it to the, I don't know, we'll check. I don't know if I added it as well. So what you have to do is follow the instructions. Before you include this file in one C or C++ file to create the implementation, you should write something like these 2 lines. You can then hash define stb assert x before the hash include to avoid using as, yeah, you can, to stop using it. All right. You can stop using malloc, realloc, and free. No, I want those, thank you. Quick notes. You've got to do this first, compile. So how I did it was, not by doing that, that's what I'm looking at, isn't it? Right, just put that back. New audio device detected. Since when? Things are acting strangely. Let's have a look in here. There it is. STB image. Alright, it's just the same file. You can tell it's the same file, it says the same things. Yeah, okay. So what I did was I wrote those 2 lines in the CPP file because this needs compiling, even though it's a header. Alright, and then before I did anything, I cleared my function from anything at all that it had in it except for return false at the bottom. And then I just compiled it using Control F7. So Control F7. What it does by doing that is it is an unused compilation. So now you've got it compiled, you leave it there, and you can come down and you can write it. Please do that first. If you don't, and you try and write your doofries, it's gonna be a bit iffy trying to write stuff. Right, so here we go, texture loader. We need a local buffer, the width, the height, and the bits per pixel. So those are your variables. We come down, we set it to flip because OpenGL does things upside down. Yay! And that's why I didn't want to do SDL. SDL flipping is very, very difficult. Well, it's not difficult, it's bit shifting. And I knew I had to do it. And I was getting a load of rubbish online, as you saw, not covering that fact. But there it is in one line. And I was looking it up, so I did it right. And I've got a correct version. Well, I've got my own version, should I say, that I actually sat down and wrote. And as I'm trying to put this together faster than sitting down and writing things, in other words, I'm using code that is validated, I use this one instead. So local buffer, load. If it don't load, push back a 0 for that texture and just return false that it didn't load. We're not interested in that one. All right, texture buffer, gluint. This is now OpenGL. Nothing to do with that header file. It's all OpenGL here. All right, let's get. Wait a minute. Yeah, I'll do pop it there. There you go. So you load your file path, which in my case is const.char file path that I'm sending in. Your width, your height, your BPP, and a 4. That's RGBA. That's 4 16 bits. No, 4 8 bits, which is 32 bits. Alright, that just tells it That's what we're looking for, and that's what we'll get. Local buffer, null pointer, get out, drop it. And now we come to the OpenGL. So we just as we did with all the vertex stuff and everything, generate a buffer. All right. Bind the buffer. I've got a texture pushback there for that buffer, so I can record which buffer number it gives us. That's just into my textures, so I can tell the renderer which one to use. All right, and this is the bit that I was talking about. GL text parameter I takes in a GL2 texture 2D macro. It takes in a min filter, which we're setting to linear. You can set it to other things. There's plenty of, look up that parameter online. There's plenty of things about it. Or if you want to know more, ask, and I shall give you information. I am not bothered. If you want me to do, actually all of these are now just going to be questions and answers videos because I'm not really teaching on this. I'm just showing you what I'm doing. So on the parameterize, I am doing the min filter, the mag filter, the clamp, which I was talking about. Remember that horrible line on the Mac that I was getting? Well, I ain't going to get it here. And the Mac actually has cleaned it up since. So I don't know if they altered it. This is your 2D texture. The image, which we store on the graphics card, not in our memory. We unbind. Once we've got it on the graphics card, we unbind and we free the local buffer because we're not keeping it. If you do want to keep it, like for a height map, then you'll have to keep that or send it off to your height map, or keep it as a variable and get it as a height map later. It's your choice. Return true. Warehouse model destroy is correct because we are destroying that local buffer there. We don't have to add it here. Lovely. VBO, VAO, and texture. That's the graphics card stuff. All right. So remember we stored it. That's another reason why we stored it. So that's your model warehouse. Very simple. Nothing going on in there. Now I have started here. So set uniform values, that's where I'm up to. And what I'm doing is I'm setting all the uniform values for my renderer. Alright, these are not very interesting, but hey ho. Location projection matrix. Alright, what is wrong with this screen? It's my chair. My chair's wrong with this screen. That's what's wrong with this screen. Chair's in the wrong position. Oh, can't hardly reach me coffee now. Bring me coffee back over here. The table has been cleaned. Oh, that's a little bit better. Lovely. Lovely, lovely, lovely. So these videos are just going to be continuations each afternoon when I can get the videos up and running of me continuing working from wherever I am, and at the moment I'm here. So I want to keep that on screen, so let's try and get a keyboard in the right place. It's a bit weird, angled. That's better. Lovely. Yeah, that's working. So I'm doing GL uniforms. Remember that I use hash common, hash include common, so I get everything. Which one am I doing? I'm doing matrix for FV. Matrix for FV. Alrighty. Pop you on. And that's going to take the shader. Dot uniform locations, which we saved when we did our shaders. And we have nicely enumerated them in hash common. Uniform location, and I want projection matrix, please. That one. Lovely. Comma. Just the one, please. GL faults. I'm not going into that one. I know what it does, and I use it usually. I usually have GL true in there because if I write the maths library, I actually turn things the other way up. So GL true would turn things into the OpenGL, but hey ho. We're using GLM, so we'll do it the GLM way, which does a value pointer. And we just open that, hit return. Current game state, everything's in there today, which is good for us. And we want our projection matrix, please. That one. Where's that gone to there? Okay. Close. And we're out. Lovely. Yay or nay? Ah, nay. Nay, nay, nay. Didn't close the bracket. Lovely. And we're out. Next. Sky colour. Right, I don't actually know what they are. So where was that CPP file? No, it's model warehouse. That's no good to me. Main game loop. That's what I want. This tells what everything is. Alright. Right, current game state. There it is. Alright, we're on to sky colour. Vec3. So that is a GL uniform. 3F, 3 floats. Okay, what do we need for this? We need a shader. Tell you what we're doing. Shader dot uniform location. There's only the program. There's only 2 things. That's nice. Very simple. Uniform. And this is sky color, please, if we've got it. Yes, we have. There we go. There it is. Close the bracket this time. Comma. And this is you looking for 3 floats, which are in game state. Current game state. Might be better. Yep, that's looking good. We can just dot that up for our position sky. No, color. There it is, sky color dot X. Well, R. Yeah, it'll do R. So, yeah, we'll use R instead because it's an RGB. There we go. Current game state. Next one. I always put a dot in because I'm lazy. And VS 2019 does it for me. It'll change it over if it's a pointer. If it's not a pointer, it leaves it. Sky color, you see, changes it to a pointer. So I want G. RG. Current game state. You're probably thinking, why don't you copy and paste? Don't. Right, I've got to get out of that habit. Well, actually, a lot of this is copy and paste because we've already got the code. But when we haven't got the code and I'm generating new code, you'll find I don't. It causes more errors than it solves. There we go, that's all we need for that. Okay. So, GL uniform. Light color. Vec 3 again. I think they're all Vec 3s now. You'll see there's some stuff missing from this part because these are general. These are all the general variables that I'm using for doing the lighting mainly, which is very nice. Very nice lighting and completely wrongly done, which is good. Against the rules lighting. There you go, that's what I'm going to call it. I'm not going to call it Phong lighting. I'm going to call it against the rules lighting. New lighting idea by me. I'll take credit for that. What we're looking for here, light colour. Oh, that's that one. There we go, there's that light colour. Why is it not changing colour? Not sure. Is it just being a dick? Visual Studio can be a right pain. Putting it in my way. Alright. Game state. Current. No, we want current game state. Current game state. And we are on a light color. Light color dot R again, please. That's just a convenience thing that they put on, changing the XYZ into RGB. It's a convenience thing, but I like to use it instead of just putting XYZ all the time, which is boring. Plus, when you read it, you think, "Oh, wait, stop! No, that's a color. Yes, thank you." Instead of, you know what, you've got a better idea of what the data is. That's all it is about. Light color. .g. Also easy to read for me. Current game state. Light color. B. RGB. There we go. That's that. That's our light color done. One sec, just make sure I'm not missing something. Location, float 1012. Yeah, that's right. Next one is light position. Vec 3. Nice and simple stuff. Hit that save button, see if that alters things. No, doesn't. GL, uniform. Uniform. I'm using 3F, aren't we? Yeah. Nice and simple stuff. So, shader. Dot uniform location. You see how easy this is to do, but it's just repetitive. That's all it is. Uniform. I want light position, please. That one. Close. Comma. Next. Current game state. This is going to be a light position. That one. And that's an X. I'm going to use X now because it's a position. And light. So X, Y, and light position X, Y, Z. You might notice I'm not using the fourth. I'm using 4F for like RGBA or XYZW. I have thought about that. And as my shaders are doing their calculations in Vec 3, and converting to VEC4 as needed, there's no point. And that is the honest truth. Oh, I've got the N key now, I can use that. I'm not on Xcode anymore. Yay. GL. I'm actually doing something with Xcode in the evenings, which is interesting, or will be interesting. I'm turning the whole of their Swift stuff into C++. Yeah, why not? You can. It's come from C, Objective-C, which is C. So yeah, it'll work in C++. I just got to get the conversions working. So Shine Damper is different. We're not setting it, is the answer. But we should be. It comes from the model. Alright. Let's have a look at our models. See the list? There it is. That's your current game state. Right. Yeah, there it is. So it comes under model position. So it's a uniform. Oh god, why did I just close that? There we go. Float. Uniform 1F. I'm guessing. I don't know. Why am I getting nothing up? Let's have a look. GL uniform. Yeah, there it is, 1F. Probably did it. I probably spelt it wrong. What we're putting in here, the shader. Shader always goes first. Dot uniform location. And it's uniform location shine damper. That one, please. Close comma. Return. Location and a float. So it's in my model. That's bad news. Can't do it. That's specific to model. I'm going to leave that as an error. So is that's those two are specific to model, they have to move. We can't do them there. That will mess everything up. Right, so why does it go squiggly now? Okay. It's telling me I've got an error here somewhere, and I can't see where it's put the error. Okay, error disappears. Alrighty, you're messing me about. It's just a refresh on the screen that you didn't do. Okay. Right, so we've got the bind texture. That's dangerous. Bind texture. That's unbind texture. So there's your unbinder. It's not in here that I want stuff, it's here. Int model. So that's a model number. Okay. So, yep, this is on a per model basis. So we've got the model number. Which model number have we got? Oh, right. We need to be able to... where's our ECS at this point in time? We haven't written it. Okay, we haven't written it. Go through here, go through here, go through here. Doesn't matter if I call it twice. That's legal. Alright. Test. There we go. There we are. We're now in test. Which model are we using? We are using model number 64. We can use model... This is notes to me, not other people. 64, which equals at. So model 64, where's your information? Where's your ECS? So the shine damper I am going to set to a value. Which one is the shine damper? I'll set it to 4 because I can. I always do multiples of 2. Oh, wait a minute. Whoa, whoa, whoa. That's 1.0, isn't it? So that's 0.5. F. There we go. I just remembered what it is. Wow. That's you done. Test. Reflectivity, GL uniform. 1F. Would it go? Yes, it's going blue on me. Have these gone blue on me yet? Oh, they've all changed now. Interesting. This is an i7 computer, which is high spec for programming. Not for running games, but for programming. It should keep up. I specifically got this specification to run VS Visual Studio 2019. Yes, that's the specification I'm actually using. On this, it's not a fast thing, but it's a good thing. Shader dot uniform locations, uniform location, and we want reflectivity. That one, comma, this one tab 2. It's an F. Interesting. Oh, you can have it, yeah. Well, no, you can't. It should be an int. That's confusing. Oh well, hey ho. That was reflectivity done. We want a matrix, which is a GL. Oh god, which one is this? Oh, it won't tell me what's in there. GL uniform matrix 4FV. GL uniform matrix 4FV. Yep, that works. This requires the location, so I'll put that in first, as usual. Shader dot uniform location. That's the uniform location for model matrix. Model matrix, there it is. There we go, comma. GL size I count, transpose, and value. Count, transpose, and value. We've got that in our current game state dot. I don't think we've got a model matrix. We need to make a model matrix. Ooh. Model position, current position. I'll need a model position, current position. Okay. We'll have to fill one of those in. says model position. Yeah, that's a big one as well. That's okay, it's a test model, so we'll fill it in. Let's give it a model position. So we can't fill in that at the moment. We've got a gap. Oh dear. We need... Yeah. I don't know how to do this. Right, so this is model position. Model position is going to be a pointer. We'll just call it test model position. There we go. Equals. It isn't. No, there's no equals. There's no new. There's no function to give me that. Okay. Oh, wait a minute. We can do that though. Equals a new. Just realised model position. We're allowed to do that. Right. Okay. That gets me out of a memory allocation. Right, so we have to go through everything, don't we? All right. Test model position dot object object ID. There we go. Equals 1. I don't care what it is. Doesn't matter to me. It's a test. Alright, this is where things matter. Test model position. Dot position. Equals vec3. Where we're going to put it? 0.0f, comma, 0.0f, comma, minus. We've got a projection matrix, haven't we? 2.0f, just to test that out. Actually, we should get a positive before we get a negative. I'll just see through the middle of the object, won't I, if I do that? Maybe not. I'm not sure. Let's have a look what we got here. Oops, did that wrong. All right. This is rotation x. Rotation x equals 0.0f. Test model rotation y set to 0.0f. We haven't set this anywhere at all in the program so far. This is all test data. You might think, oh, that's a lot of test data, but trust me, it isn't. Rotation. It means a lot can go wrong. Like I can mess my test data up, but really, this is telling me what I'm going to need to do to get things working. What's this one scale? Equals 1.0f. We could do 0.5. No 0.5f. I'll test it. I'll test it. Don't mind. Rendering. Alright, I can do that. Test model position VAO. The ID for the VAO is a pointer though. No, it's not, it's a handle. Model warehouse. Request handle. There it is. And what's asking for? A Gluint model ID. Oh, we've got that, haven't we? Nope. 40 ID 64. Test model. There we go. See? I'm good at this, aren't I? Hey, indices, num indices. Num indices equals. I should really pass the model in. But as it's a test model, it doesn't really matter, does it? Model warehouse has got that information. Model ID 64. There we go. I'm not overly confident in this because I've not tested model warehouse. Yeah, that's right. Wow. Interesting stuff now. Because, oh no, it isn't. I know what I'm doing with this, yeah. Test. Let's do it properly. We are after next the model matrix. And that will equal, and I've looked it up now, so I'm more than happy to put a vec, no, a mat4. Mat4 1, which is correct. I have looked that up. It means just create an identity matrix. If you don't know what an identity matrix is, please just ask. That goes for everything, absolutely everything. This is supposed to be a chat show. If you want to come along and chat with me and say, hey, look, I really don't understand all of this rubbish that you're typing in. Could you go through like everything in model, test model, in how you go about, you know, like rendering the test model, and why you kept these values, and how did you know how to keep them? Is the most interesting question, I think. The one that's more in depth, anyway. Model color. GLM, we can make anything that we want for this, can't we? Vec 4. I'm tempted to put Vec 4. So 1.0f. Oh no, it's testing at 0.0f, comma 8. No, don't do that. 0.8f. Should be at half. 4f, comma 1.0f for the alpha. Thank you. Oh, I've sorted my blend function out as well. I'm happier now. I've just left it and left it and left it for ages and ages and ages. We've gone through how many iterations now? This is the 3rd iteration, so that we're on to alpha testing, and I still hadn't done my blend calculations. That is amazing. Let's do shine damper. Test model position. We'll set a shine damper up. What we're going to put it to? 0.5. That means I've got this in the wrong place, haven't I? Don't know why it does that. And the last one is... What is wrong with this thing? Oh, right, there's no semicolon at the end there. Test model. Let's do it properly to show how it goes. And we are now on the reflectivity. This is the kind of information I want for every single model. This is our ECS here. 2.0. I'm just bypassing it. Bypassing the ECS system, that's all. Right. Semicolon. Okay. That 0.5f is now test model dot shine damper. There we go. That 2.0 is now test model. You can see how it makes more sense when you do it this way. Reflectivity. There we go. Everything's happy there. Uniform location we haven't done. What we're looking at. Model matrix. That's that one there. That's what it asks for. Oh, sorry. Right, so that is an asterisk. That's fine. That is our model. No, it's our test model. calculate model matrix, and it's just asking for current position. So that's test model, and it's an arrow. Current position. Right, so that's calculating the model matrix. That's good. Anything else we need to count? Oh, right, yeah, I'll do that in a minute. Model color we've got. Vec4, yeah, different. So we got tier, didn't we? So there's a GLM thingy to go in there. GLM, a value pointer. Wish they hadn't have done this actually. GLM value pointer. I don't trust this value pointer as far as I can throw it. But don't quote me on that. We've got problems with it. No, we haven't. What we're looking for. That one. That's fine. That's fine. That's fine. Good one. We'll take it. If you notice on tests, I don't put all the spacing in. So I know that it's all part of the same test. You can see how much harder it is to read. Wow, it's colour blindness there. Calc model matrix is upset. Hash include source. Oh god. Try again. SOUR tab Amber Maths. There we go. Matrix utilities. Save. Close. Why did we do that? We've got something wrong here. No, we haven't. No suitable conversion function from GLM Vec3 to model position. Whoops. Just send it in there. It'll sort it out for us. Lovely. Alright, we've got this one to do. And this is going to be OpenGL uniform. And we're on a color 4F. Okay, we'll go with that. And we shall start with location shader. Uniform. location. Open uniform. Model color, please. That one. Close comma. Now this is where it gets a little more interesting. It's a color, isn't it? Okay. Get our test model position. We will look up our model color. And we'll do op.r, comma. Test model, model color, G, test model, yikes. Model color, B, RGB, and there's a fourth one. Model color, alpha, A. RGBA. Right, so I've got everything. According to that, that's wrong. 64. Yeah. Yeah. Test model loaded up. Parameters loaded up. Have we done projection? That's the other one. Yeah. And we do set that. That's important. Done that one. That's the position of the camera. The view matrix. We didn't do the calculation for it. Because I was being lazy. That's bad of me. Calculate camera view matrix. We've missed using that. It doesn't go here. That's why. It goes after input. Goes in here. Game state current equals that delete that that's why we haven't got it done. We haven't introduced it to camera, have we? Okay, that's fine. I've got a note for it now. which means that's fine. Alright, get back and concentrate with this. All looking good, all looking good. Ignore, ignore, ignore. Let's do a test. Am I happy with all the information I'm testing with? Yeah. Control F7. Alright. It'll build. Just going to give it a quick run. See if we get a crash. Here we go. Glad about that anyway. Right, I've got a vector subscript out of range. I know why. Abort. Thank you. Which means I haven't got a return. I'm missing a return value. Which one? Build. No, debug. Start debug is F5. Alright. Try that then. F5. Oops. F5. Good. Retry. Thank you. And it's under the request for the index. So we did get to render all. Wow. We got all the way through to rendering and hit the model index. Why wouldn't I have one? Because that is set in the model loader and we jump out and we never set it. I've done my model loader cack-handed. VAO storage pushback, yeah, great. But it hasn't got any of the others. So what else do we set in here? We set the VAO. But look here. We have a VBO. So we have to set one of those as well. That's going to be awkward. That's going to try and delete. Okay. Right, deletions are now wrong. Okay. So that covers your index buffer. Right, we want the index count. This is awkward. I'll leave that as an error for a minute. Oh god. This is worse than I thought. Alright, slow down. We've got an index count. Just got that. Then we've got another VBO storage. Two. Three. Three. Right. Gotta think carefully about this. Got a problem with that. I've got massive problems with that. They're all gluing, so I can't put a -1 in. Alright. Did we have a max entities? That's an interesting question. Stop this program. Now I know what's going on. I know whether this is the mistake area that I've made. Do we have max entities? Common. What defiance have we got? No, we don't. Will we have max entities? Do we want to have max entities? It's within the original format to add the variable or the variation. You look as though you're sitting there ready, waiting for me to stop speaking, Muppet, and then you can speak. If you want to speak, go ahead. He's sitting on the other side of the microphone, looking at it, staring at it, with his little tuxedo on. Oh, bless him. Yeah. Decisions time. I've got cold coffee. Let's have a look over here, see if I've got anything else. Decisions time. The first decision I'm going to make is let's have a cup of coffee. Now, if anybody wants to help me make this decision, you're free to put in your 5 pence worth right now. Sorry, your 2 pence worth, 2pence. Be right back. You've got 3 minutes to tell me what I should do. This is an important decision. We have a choice of restricting max entities to a sensible number or to a fictional number. In other words, something that's never ever going to happen. That's a fictional number. No idea what that could be. I mean, I would just put 99999 in or something. 9,999. I mean, that's a possibility. Or we put a sensible number in, which is 1024. What I would call a useful cap. And if it's useful, I have to do a hash define. I have to hash define anyway. Otherwise the value's too hard to track down later. So if I'm going to have to do a hash define anyway, we may as well make it useful. So 1024 though is quite low. So it will be revisited, and it will have to be revisited. We won't have a choice in that matter later. I think with a single player game, we will reach 1024. As soon as you go multiplayer, there is no maximum. What values is this going to cover? C++. Max value for 32-bit unsigned int. 4,294,000. 4294 967 295. That's still a low number. Or is it billion? That's 900,000. That's 1 million. So it's 4 billion. That's better. Hmm. Four, 1, 2, 3, 1, 2, 3, 1, 2, 3. There you go. 4 billion. 4 2 9 4 9 6 7 2 9 5. I'll leave myself a note. No, that's wrong. That's it. So all of these numbers, oh, index count. Finish my tea. Finish my coffee break. Let's get you back online here. There we go. Right, so I've introduced, during my coffee break, I've introduced max sensities. Here we go. Those are the numbers. 4 million. Problem that I've just looked at is when I looked straight down there, I got to this one and went, whoa, that could be a lot more. No, it can't. It would have an overflow. Okay. Actually, no. Do it properly. Yeah, we'll have the +1 in. I'm just thinking about the rest of the code. How the code is going to handle that. I want a greater than sign. I want greater than or equal to. I want that to be a true fixed topper. That's legal. Right. Alright, let's do our debug test again and see if... Start debugging F5. Right, okay. Got to get used to using F5. F5. Here we go. Alright, it's all working. And we are on render time of 1 millisecond or under. Okay. That's alright then, I can continue. I knew there was an error somewhere, I just didn't know where it was, and that was it. Because I was just dealing with things that are incomplete, shall we say. I'm doing a test. So as soon as you start doing test numbers, you have to find what incomplete part has to be completed. We found it. That's what would have been done anyway as soon as we introduced the ECS system. Alright, let's go into deeper troubleshooting now. I know there is some. Okay. So in our archive, under Sandrogue, we will have a renderer here, written in C. Okay. So we do the same thing. We go through all of our uniform locations, put them in. Alright, I've just cheated here. Magic numbers, yes. Well, we don't have magic numbers no more. Which reminds me to check that sky colour. I'm glad I looked at this now. Yeah, we put the right one in. Yes, that's okay. Camera location we've done. We decided on that one. Rendering a dungeon map we're not doing. And then for each render, for each item we go through, we've only got one, so we're cheating. We set the VAO ID. That might be a good idea. The VAO ID. Who's got that? That comes with our test model position. Alright, so this is the next, these are the final stages for rendering. So GL bind. Have we not already done vertex? Hold on a minute. Make sure I haven't already done it by accident. No, I've done the shader program. Even that's a bit early. No, it's not. Alright. We only have shader and current game state there. But as we come through, we are adding variables. The only variable that we've added is this model position jobby. But that does hold our 64. But that will be wrong. We have to introduce another variable. Otherwise we're in trouble. 64 is not the answer. This time. In common, we should have a struct for this. Oh, we do, it's here. So it is in model position. That makes rendering a lot easier. What have we just set them to? Model warehouse requests, correct. So we have got them stored. Fantastic! I'm one step ahead of the game in this one, aren't I? So let's bind up this vertex array. Vertex array. to our test model, position, and it's going to be VAO ID. Lovely. That worked nicely. Game model calc model matrix. We've already gone through that, haven't we? Yep, got it there. So we are storing the correct model matrix. Alright. What the heck was that? Was that you? Yeah, that was pudding. Uniform matrix, send up the model matrix. We've done that. So all we need to do now is draw elements. Right, I'm not happy about the ordering here. Order matters. Yeah, we've got something wrong here. After putting, that's the first thing that goes up. Per model data. There it is. That's an OpenGL call. You don't do your OpenGL calls and then do your data. You do your data and then the OpenGL calls. That's the first one. This is new. So we'll put our new GL texture in there, which we get from the model warehouse. We're having texture number 1 for our test. Anything else to do with textures up here? Alright, I'm taking you out because we're getting the order correct now. That's not test. That's not test. That is test. Mark it. There we go. Right, non-test. Right, we're safe. That has to go there because we're loading up values. Damn, this is looking good. Alright. GL draw at long last. Elements. That one. And the first thing it wants is, yeah, okay. That's alright then. GL triangles. Comma. Count. We have stored it in test model position dot index num indices. Alright, we're okay with that. And this time I'm not lying to it. I'm going to actually put in a GL unsigned int. That one. And we are going to do this properly. We are going to do the void star. Void star 0 is a null pointer in C++. That is correct. Me happy. Coffee! Because as you look here, we've run out. Okay. So it was F5, wasn't it? Yeah, cool. Access violation, reading location, blah de blah. And this is on 2. This has never come up before. Why? Right, this is the model warehouse. This has never reared its head before at all. It's coming from the end of the create for the model warehouse model loader. The last path. Take the equal sign off. Stop. Close Windows. F5. There we go. We're up and running. As you can see, we are still not doing anything. The screen is blank because that's exactly what I thought it would be. Always is the first time you run this, usually. Should be anyway. There's no way I've got it in the right place. Right, okay, position. The first thing you do is move your model 2. Alright, press F5. We've got something at long last. Can I see it? Yes, I can. Just. And I've got a non-resizable window. Right, you're not going to be able to see this. Mind you, neither can I, really. I don't know how much it's drawing. Change background colour. Yeah, it's right, it's doing it. It's correct code, but some of the numbers are wrong. Which in theory, I already knew. Because I made them wrong. Get rid of this window. I also know it's wrong because we're still under 1 millisecond. Mind you, drawing one object under 1 millisecond. Yeah, okay, I'll go with that. What I'm going to do first of all for testing and testing only is come down here, RGB. Actually, no, what I'll do is I'll add 5 to all of these. And we'll try an F5 on that. And it's come back to here. Okay. Texture coordinates. Yeah, there's a texture coordinate there. Oh, dear. It's got past the code that's wrong. It's that's the one I thought it was doing, and it isn't. It's on the correct object, 64.obj, which we do have. It's 1, that's correct. Interesting. Yeah, that's right. It doesn't bring these up. Alright, that's indicating the end of the for loop. Or we're in the for loop and we are on count 64, of course, yeah. Alrighty, so 64's not allowing us to get our texture buffer. The pointer's... is it the pointer that's going to be wrong? (1,336 vertices), is that correct? Seems a little high. Oh, no, it isn't. That's correct. Yes, I remember the number now. No, it isn't too high. That's okay. That attribute pointer. I need to look into the attribute pointer. Or this. Right, so the error had nothing to do with the thing I changed. which was that equals sign. The error has more to do with outside of a vector range. It's going outside of something. Right, that's back to normal. Hope it gives us that error. Right, now we can see it. Yeah, there's the error. We've got a little line. Oh, I've got a control thing here, haven't I? Here. Right here. There. Our process memory seems a little high, but it's not increasing. Render time is 1 millisecond, if that. CPU is doing bugger all. We have. Now we sit and think. Okay, so it'll run once and then it'll fail once. So that's what I call unstable. Very unstable. Now if I remember rightly, I just plonked that textures in, didn't I? I didn't even bloody check it. I think I've guessed at something. Yeah, I did. Ooga. Right, okay. I've guessed at something and that's what we've got. Which is obviously wrong. So our model warehouse under create. So we are getting to 64.obj and we are trying to load it. I haven't come across this error before. I think it was because we weren't trying to draw it. It's reordered this. It probably factored it out of the original construction. Yeah, they can do that. Just trying to think how to check this. Oh, I've got a void zero star in there as well. That's no good. Please don't have that. I've got another one here. I mean, it's been accepting it, but it shouldn't. Not on C++, that's interesting. See, I think this is where the error is. I don't think it's got anything to do with textures. But I never checked the texture code. So that's our next job. Texture code. Okay, what are we using? Asimp. Ah, now you see. I never looked it up properly. Ah. Gotcha. We're not getting the texture from there. I don't want those, I just want the coordinates. Dumbo. Let's go for texture coordinates. M meshes, text coordinates. Mesh. That's num vertices. That doesn't match up, does it? Okay. Mesh M text quad, yeah. There isn't a num. So we had to calculate it, so we calculated it from that, didn't we? Num vertices. That's dangerous. That's not correct. Damn it. I think we've hit the problem. Mesh model. Ah, texture hello triangle. Yeah. Yada yada yada. Building assemp. No, thank you. This is not going to get out. There's an easy way of looking this up. Where is it? Oh. It's assemp. Text chords are not stored in a flat array. Ooh. Really? Oh yes, I remember this site. This was the good site. Yes. Cube. That's no good to us. Where's this texture coordinate business? Oh, number of textures attached. And that gets the path. Array of texture coordinates aligned with the vertex array. Interesting. Which is why I put num vertices there. Yeah. It's this one here. Right, but I need to know the num. Okay. That's showing it separate though. Num faces. times 2. We could use that. That'd be times 6. Alright, that's materials, structure, vertex positions, normals, texture coordinates. Here we go. Size of float times 2. Mesh num vertices. 2 times mesh num vertices. 2 times mesh num vertices. Size of float, yeah. Size of float. Alright. Go through the array of texture coordinates and copy them to a one-dimensional array. Note that in Asym, the texture coordinates are not stored in a flat array. The texture coordinates variable in an AI mesh is a 2D array. You numpties. Alright, so that's what we've got to do then. That's why it's not working. We're only getting half the textures. We're only getting half the texture coordinates. We're only reading that. Well, God knows what data we're actually reading. It'll just be splatter data, really. Yeah. That's lovely. Alright, let's put some extra code in then. What shall we have? We can have a float. Float. Star text. Chords. We're not using that anywhere, are we? Texture buffer. Okay. Equals float star malloc. And it's the size of, well, it's that there. That should do it. Okay. I'm not splitting this down right now. So, 4. We're in OpenGL, aren't we? I can use a glue int. Is that wise? No, it's not wise. There's a big reason for it. I'll do it longhand. What am I calling my stuff here? I for index. Okay, follow that. I equals 0, I guess. It's got to be less than. That's interesting. I don't like why it's less than. Yes, okay, I understand why. Just don't like the understanding of why. Copy. Alright, do that less than. And we'll just increment I in a polite fashion. What we need to do is get the text coordinates out. Don't like this. Yes, I do. So let's take our text chords. Now they're in twos, so we need to get I times 2 in there. That's going to equal mesh arrow. It's going to be M text chords. There we go. And it's going to be, in our case, it's going to be texture 0. We haven't decided on how many textures, so it's just texture 0. That's the default area where it's going to put stuff. I'm going to put that to I, and that will have a dot on it. Yeah, it does. It's a U. Doesn't have a U. An S. Doesn't have an S. Okay, it's an X then. Dear me. That's not good. Bad programming there somewhere. Text chords. We want the second one as well, so that's I times 2 plus 1. And that equals mesh. No, don't get in the way, Muppet. I know, I love you. Texture chords. And that's going to be 0. I. That's going to be a dot Y. There you go. That transfers it all over to text chords. So we go ahead, we generate our buffer, and we store our buffer for deletion later, and interesting things as well. What else we got? We bind the buffer, and then we need to transfer the data. So what do we got? GL array buffer. It's the size of a float times 2 times mesh num vertices. God, I got it right. Wow, I got something right. This isn't right anymore. This is going to be our variable. Did I put text chords? No. Bloody did. It's got nothing to do with text. It's texture. Thank you. Stupid me. Don't get those two confused. Otherwise you'll have a very bad day. Got nothing to do with text at all. Static draw. Yeah, I'm happy with that. We enable the attribute array to 2. Yeah, that's right. Ouch. So it's 2. Oh. I'd forgotten about that. 2 GL float 0 0 0. Correct. That's what I've got. F5. Awesome. That's working now. There we go. So I've got our little diddy line there in the middle, which is what I was expecting anyway. So we've got it right. It's doing it right. OpenGL is now working. Our program isn't. So I'm going to take... Oh no. Of course, yeah. Just go back to my... I was trying a different thing. This is actually a test of a different piece of code. I'm not testing the rendering here. I'm testing this index loader here, where I've changed it from face array over to just dump the indices in. And for the same reason, I'm just going to go back to indices on here and have a look. Yeah, I'm going to redo this because I don't like it. So face array. Might just be using you. So I'll pop you in. This isn't right. I just wanted to test it to see if it would work, but for the same reason that the textures didn't work, this is the same. But I don't like doing it this way. Which is the reason why I was messing around, shall we say. Right, face indices elements. This is a GL element array, isn't it? Yes, it is. Let's do it properly. For starters, get rid of all this code. I don't like it. I really don't like it. Let's start from scratch. Yeah. Right. Right, what did we use? Face array, was it? Yeah. Copy. We need a one-dimensional array, exactly the same as we did for the textures. So here we go. Did I use a glue int for the textures? Yeah. No, it's a float. Sorry, I'm just double checking myself. Alright, unsigned. I'm doing it in full. Unsigned int. Because that's what it is. We're going to use face array. We're going to also make that into a pointer. Face array. What's this going to equal? It's going to equal an unsigned int, isn't it? Star. And this is going to be malloc. Yeah, open brackets, close brackets. And it's going to be the size of, easy to do these really, unsigned int. And that's going to be multiplied by mesh num faces, please. Yeah, num faces times 3. Yeah, do I agree with that? Yeah, it depends where in the code you put it, I suppose. No, it doesn't really. Here I'm using num faces times 3. Num faces times... Yeah, keep it consistent. Yeah, happy with that. Fine. That'll do. I'm just wondering if I want to bracket that off. No, it's multiplication, it doesn't really matter. Sorry. Coffee. Don't die. It's stored in a one-dimensional. Interesting. I'm going to need an extra variable here. Unsigned int. No. Face index. Hold on. That's just a normal. Right. The face indices are stored in 2 layers. There is an array of AI face, and then each AI face stores 3 indices. That's what it says in the manual. So we're going to need a for next loop. For unsigned in. Yeah. And we're using I. I needs to stay less than mesh num faces. Yeah, I'll go with that. There it is. That one. And we can just increment I through each face. So for each face, what we're going to do? Alright, const AI face. This should come up. Maybe not. Oh, it is. Face. AI face. Yeah, it seems happy with that. It's gone the right colour. I'll use it then. Star face. So this is our actual face that we are going to be interacting with. It's a pointer. So I need the address of mesh m faces, and it's going to be I, isn't it? Yeah, that's looking right. Right, so that gives me the face. We'll take it. Right, we've got a face. What should we do with it? There's three indices hidden in this. So we're going to do a mem copy, because we have to do it this way. We don't want a shallow copy, we want a full copy. And this is where it gets awkward. So it's and our face array it's getting everything in the right order at face index Yeah. Index. Do I want a plusser on this? No. Right, okay. Go with that. So we're going to do a block of 3 from face, whatever it gives us. I think it's that one there, indices. I think it is. Does that look right? Yeah, this thing, memcopy will now ask how many bytes, size T size, yeah, how many bytes we want to copy. So, well, 3, well, how many, objects do we want to, unsigned thingies do we want to copy, unsigned, int. Is it the size of, yeah, it will be. It is bytes. Close, close, semicolon. Does that look right? Yeah, I'm going to agree with that one. And then all we have to do is increment the face index by 3. So face index plus equals 3. That'll do it. Let that roll around. And see what we need. We need a buffer. Store the buffer. Then we bind the GL elements array. Here we go. Yeah, we're okay up to there. Transfer our face array to the vertex buffer object. Face. Okay, we've got a construction here. So num faces, mesh. Alright, so why have we got that construction and that there? Are we idiots? One second, I'm double checking myself now with the instruction manual. No, I've got something wrong here. Alright, let's try looking at this one and seeing what they're actually doing. Transfer face elements, here it is. Right, found theirs. GL element array buffer. Yep. Size of an unsigned int. I've used gluint. There's a difference. Okay. times mesh num faces times 3. Correct. Given face array and make it a static draw. What's this construct for? I can't see why there's a construct here. There's that. Do I need to go through every face? No. What did I mem copy? Or assign? No, I assigned it directly to face array, so now I can free that. I don't need this variable. I don't understand what that's for. It's for nothing. Debug F64 F5. Uninitialize local variable face index. Pardon. Really? C++? Really? F5. Alright, and that's what we got. Our little ditty line. Get rid of that. At this point, that's the textures. Textures are okay. The model's okay. I wonder. How'd you send this thing round? We're getting that there. That little line there. Build. Rebuild solution, please. vertices, yeah. What was that number? 1,300 and something. Oh. Yeah, that's about right, because it's 3 times that. Right. Well, something like that anyway. VT. Okay. How do I set a breakpoint here? Oh, it's here, is it? Yeah, F5. Right, so we are on model number. Why hasn't anything else come up? Ah. What? Oh, sorry. File path. Here it is, 64.obj. Got. Right, we're on 64. Let's have a look what happened, shall we? Where's me buttons? Ah, here they are. Step over. Okay. Size equals 64. Oh, of course, yeah. VAO storage, size equals 64, yeah. We're on number 64, okay. Okay, we come down here. Alright, I want to look at this. Alright. I'm not sure this is doing things right. For starters. Alright. Step into... Where's continue? Ah. Alright, so at this point, what do we actually have? We have 2,928 on our index. And we have a face array. Yeah, it won't show anything there, will it? Continue. That's what I wanted. Index count. Look at what the index count is. What the hell? How come I've got my max indices in there? Sorry, max chaser. I don't understand. There's something wrong here. That tells me why everything's not working. My index count is... not right. Oh yes it is. I'm looking at the wrong variable. Ha! Zero. How to get to the values? That should have values in it. Alright, let's have a look at these. Face array. 0. Something's wrong here. Face index 2928. File path correct. Index buffer correct. VAO buffer, well, correct. This index stuff isn't. Nine seven six times 3. 2729. Yeah, that's right. That's correct. That is definitely not correct. Oh dear. Alright, we're going about this the wrong way then. There's another way of doing this. And it comes from this face index. Right, let's leave what they've done. Let's see if we can do a C++ way of doing this. So what we need is... sign in, yeah. Okay. get the face. So we're working with whatever face we are currently on. I like that. And we want to store face array. Face array. Now that's a pointer. Alright, okay. No, face array. Face index. Yeah. Equals. Now I'm getting a bit wary. Face. It's a one-dimensional array, isn't it? Let's read their notes on indices. Stored in 2 layers, there is an array of AI face, and then each face stores 3 indices. So I've got the face. So let's take that face, and I will have 0. All right. Mesh M faces I dot that's an AI face. What does an AI face have? It's just dot dot dot. Eh. We're not getting anything here. Face dot. It's the same thing. That's just replacing that, that's all. And now it doesn't like it, thank you, because I didn't like what I was looking at either. And it was because that went to a dot. Increment the index each time. Takes those two lines out. Alright, stop. F5. Ah, damn it. Get rid of that damn thing there. Alright, just keep the windows out of the way and I'm going to watch that window. Right. Okay, so continue. Alright, continue. 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 Okay, face array. Trying to free up face array. Alright. Stop. And F5. Continue. Right, it's only giving me one underlining there. That's interesting. And we have changed it. What into? I have no idea. Continue. Still says 0 on it. I'm going to change this into a vector. Continue. I don't like the way they're doing it. I agree with the methodology, I just don't like the way they're doing it. Right, let's have a look at this face array. See what we can do with it. What we can do is have a vector, an std vector. Now, OpenGL hates these damn things, which is why I've been trying to avoid it. Now, what kind of vector do I want? Well, it's gonna have to be out in the wild. That's okay. What I'm going to do then is I'm going to push back each one of these. Here. So it's push back. A new unsigned int. Do I need that? No, I don't. That one there. Alright. You do that 3 times. With 1 and 2. And that gives you an array. That also gives you a problem. You've got a vector, which is not OpenGL. We should be starting to get errors here, we're not. But that is asking for... Definitely not that. It's asking for the address of 0. That. That's a definite 100%er. Will that face array do it? Hello, Poppy. What time are we on? Oh my god, are we? Whoops. F5. Equals a new unsigned int. What's wrong with the word new? Oh! That's incorrect. It equals a new std vector assigned int. There we go. Really? That's a little weird. It's asking me to change these to glue ints. Never encountered that one before. Right. Now it's reversed me. Control Z back. What happened here? Something's weird's going on. That should just say vector. Yeah, I agree with you a lot. That was a bit whiffy. Nice. Continue. Wait a minute. Face array. Now has... Whoa, it's got things in it. 3597. Okay. Continue. Oh good, we've lost the line going across the screen. Thank God for that. Right, so that's what we've got, just a blank. There is no dots in there, is there? Oh, perfect. That's good. Now I've completely lost it. That's better. F5 it again. Right, so what's happening here? We have face, size, 2928. Am I in the wrong thing here? This is says that says vertex buff here. Index buff, here we go. This doesn't look right here. Yeah, stop. Why have I got mesh on faces and it's right what it's saying, but is it right what it's doing? And sometimes it's not what they are doing that matters. You see, we've just changed it, so we now have a face array. And that has a size. F5. There was an error there somewhere. And the error is value types here. I didn't cast it over, did I? Capacity is totally different to the size anyway. Can I get a value? Will you let me have a value size? No, you won't. Okay. Let's give it here. Okay, continue. Here we go. Now we've got it. There it is. Right, what that tells me is our data is going through garbled. But we do have our data on screen at long last correctly. Which means that somewhere along the way those faces aren't going through properly. But that looks, it could be an indexing problem. Is that an indexing problem? Could be. But we're getting there now. So that's it. That's today done. Cats are stopping me. That's our first 10 test model on screen. How's about that? So under this, I go to, God, it's got 99 plus here. What the hell happened? Why did all those archives change? Okay, something's been altering my stuff. Compare with unmodified. Ah, interesting. Where's my archive? Here you are. No, it's still there. We added it in. Have I been changing the wrong things? To these one items, yes. Something wrong going on there. Yeah. Something dodgy going on here. Changes 1,400. No, there isn't. What happened to my git ignore? Yeah. Right, I'll sort that out off screen. Anyway, in the meantime, that's it, folks. Got to go and kill. Oh, nope. No. Don't kill anything. I've just got to go and feed the cats. They're all being very good about it, so I'm going to feed them and make them happy with some gravy. Do you want some gravy, you lot? I've got some gravy for you. Yeah, they're looking at me quite nicely. In the meantime, take care and have fun.